Hello and good afternoon, everybody. I welcome you back, one and all, to the lecture class on experimental epidemiology. If you recall about this experimental epidemiology, it is one of the epidemiological study designs among the various epidemiological study designs. The epidemiological studies or study designs are basically divided into observational studies and experimental studies. Observational studies are again divided into descriptive and analytical. Analytical studies are again divided into 4 types, of which case control study and cohort study are very important. And experimental epidemiology study design is basically again divided into 3 types: randomized controlled trials, and field trials, community based studies. In the subsequent classes, we will be learning in detail about these different types of epidemiological study. In today's class, we'll be concentrating on the randomized controlled trials, and what are the various steps of randomized controlled trials, and what are the what are the various designs of randomized controlled trials. In the subsequent class, we'll be discussing about the various types of randomized controlled trials and what is meant by non-randomized trials and what are the various types of non-randomized trials. So in 1920, experimental epidemiology meant the study of epidemics among the colonies of experimental animals such as rat and mice. In modern day usage, this experimental epidemiology is now equated to the term called randomized controlled trials. Now, randomized controlled trials or experimental epidemiology are, to start with, are similar to type of to that of cohort studies, except that the investigator has in control the factors that are responsible for effecting changes in the experimental group and the control group, which is not there in observational studies. Experimental studies and intervention studies involve usually some action or intervention or manipulation, which is subjected to an experimental group and is compared to a control group, and which contrasts sharply with observational studies where the epidemiologist doesn't take any action but only observes the natural course of events or outcome. Now, what are the various aims of experimental studies? To provide scientific proof of etiological factors which may affect the modification or the control of these diseases, to provide a method of measuring the effectiveness and efficiency of health services for the prevention, control, and treatment of disease and improve the health of the community. So when you talk about public health, we need to understand about how the health services are functioning, whether it is they are effective or not. And experimental studies have helped in understanding about the failures or success of these health services. Experimental studies have the advantages and disadvantages of the usual prospective studies, plus 3 additional problems. That is the cost. There is a huge cost involved as far as the conduct of the experimental epidemiological study designs are concerned. There is also the question of ethics, because when human beings are subjected to various maneuvers or interventions, there may be risk involved with the human beings, and which may also affect the life feasibility. Many a times, feasibility of experimental studies is not possible because of the conditions are not favorable, or because of or due to the lack of availability of human resources. So basically the experimental studies can be conducted in animals or human beings. Experimental studies have been the basis of most of the epidemiological investigations and epidemiological studies. Animal studies. So time and again, and in time immemorial, the animals have been the subject of humans' quest for knowledge about themselves as well as the environment, and they also helped in understanding about the various aspects of anatomy, physiology, pathology, microbiology, immunochemistry, immunology, genetics, and various other aspects. So previously animal studies were conducted way back in US by the noted epidemiologist by the name Webster. Subsequently, Topley, Wilhelm and Greenham, Wilhelm and Greensham also have conducted experiments, classical experiments in animals to study epidemics in animals, and also to study herd immunity in animals. So the important application of animal experiments have been experimental reproduction of human disease in animals to confirm etiological hypothesis and to study the pathogenetic phenomena and mechanisms. So to understand about the cause and effect of a particular disease, and also to understand about how the various pathogenic mechanisms, to study the natural history is also important. What are the various pathological changes that occur is only because of animal studies. Testing the efficacy of preventive and therapeutic measures such as vaccines and drugs. So before trying against human beings, such preventive and therapeutic measures are tried in animals, so that if there is any effect in animals, that they can be subsequently be used in human beings. Completing the natural history of disease, that is a pre-pathogenesis and pathogenesis phase of any disease. So many of the diseases in human beings are also seen in animals, like leprosy. There is a natural history of the history of disease of leprosy in 9-banded armadillos. So animal models serve as good indicators of the pathogenesis of disease and subsequently application of preventive and therapeutic measures. So what are the advantages of animal experiments? Experimental animals can be bred in laboratories and manipulated according to the wishes of the investigator. They multiply rapidly and enable the investigators to carry out certain experiments which in human populations would take several years involving many generations. So since if you have seen about rabbit or guinea pig, they multiply rapidly and huge numbers of these animals can be used to carry out the investigations, unlike in human populations where it will take several years and it requires many generations to carry out these experiments. So what are the limitations of animal experiments? Not all human diseases can be produced in animals. So many diseases in human beings, they cannot be reproduced in animals. So in such a case, animal experiments fail. All the conclusions derived from animal experiments may not strictly be applicable to human beings. So this can be very well be understood by WHO experiment of typhoid. So it has been found in laboratory animals when the 2 types of vaccines were administered to 2 groups of laboratory animals. It was found that alcohol killed and reserved vaccine was more effective in animals compared to heat killed and phenol preserved vaccine. But when the same result was applied to human beings, it was found that alcohol killed and preserved vaccine was not effective to that extent as heat killed and phenol preserved vaccine. This heat killed and phenol preserved vaccine was in fact first propounded or was first done by Almond Wright. Almond Wright was responsible for this typhoid vaccine. Human experiments. Human experiments will always be needed to investigate disease etiology and to evaluate the preventive and therapeutic measures. These investigations are more useful and more essential in the investigation of diseases that cannot be produced in animals. So James Lind experiment, which he has conducted among 12 soldiers, and which he divided into 6 groups, and all these 6 groups were administered different types of diets. To one group, he specifically gave 2 oranges and 1 lemon, and all these soldiers to whom the diet was administered, different types of diet was administered, were suffering from scurvy. So in this experiment, James Lind could find out that the group to whom the oranges and the lemon were served, they recovered from scurvy, and others did not recover from scurvy. So by this, he could prove that citrus fruits, especially oranges and lemons, if given to people suffering from scurvy, will result in cure of the scurvy. So the group to whom the lemon and the oranges were served. They were known as limeys, Limeys. The Edward Jenner's experiment, the cowpox vaccination, in which he was able to start the smallpox vaccination, and the terms vaccination, vaccine were all derived by his experiment, and it was because of his experiment we were able to have this smallpox vaccine, and which we were able to control and contain smallpox at the time. Finlay and Reed's experiments, again, they could say that yellow fever was due to was mosquito borne, and they were able to see this. And Goldberg's classical experiment on pellagra proved that pellagra is not due to infection, is not an infectious disease, but is due to deficiency of nicotinic acid. So this is the image of James Lind, who was responsible for the prevention of maritime diseases and cure for scurvy. Then this is a picture image of Edward Jenner, the person who was responsible for smallpox vaccination. Now these are the two scientists who were responsible for saying that yellow fever is due to a mosquito, which all of you know that it is due to Aedes mosquito. And Joseph Goldberger proved that pellagra to be a nutritional deficiency, primarily nicotinic acid, and not caused by any infectious organism or infectious etiology. Since then, human beings participated in the studies of malaria, syphilis, hepatitis, measles, polio, and others. Although the experimental method is unquestionably the most incisive approach to scientific problem, ethical and logical considerations often prevent its application to the study of disease in humans. The World Health Organization in 1980 has laid down a strict code of practice in connection with human trials. Experimental studies are of two types: randomized control trials, that is random allocation, where the population is subjected to randomization and divided into randomly into a experimental group and a control group. Non-randomized or non-experimental trials, where there is no randomization is involved, and the groups are formed naturally. Randomized control trials. Randomized control trial is an epidemiological experiment. The design of a randomized control trial can be understood in the subsequent slide. Design of a randomized control trial, or RCT. First, what we need to do is select a suitable population. The suitable population is also known by the names called reference or target population. From the reference or target population, by various sampling methodologies, you select a suitable sample, and the suitable sample is also known as experimental or study population. In this experimental or study population, you make necessary exclusions by finding out those who are not eligible, to participate in the study, and those who do not wish to give consent. After making these exclusions, the rest of the experimental or the study population is subjected to a process called randomization, which is a statistical procedure, where subjects are allotted into two groups based on this random number table, that is the experimental group and the control group. And subsequently, any intervention is done. Any intervention like addition, deletion of a particular substance or a drug, or is done in an experimental group, which is also known as manipulation. But in the control group, it is not done. So control group is either given a placebo or left like that. And subsequently, after manipulation, it is followed up to see whether the experimental group to whom the drug or intervention or manipulation was done, if there is any positive or the negative result, and this is compared to the control group, and it is further assessed to see whether this can be applied to the rest of the population, that is the reference or the target population. For new programs or therapies, the RCT is the number one method And the various basic steps in conducting the RCT include the following. So these are the procedures which you must know and by rote it, so that this comes as a long question in university examination. So the first step is drawing up of a protocol. Second step, selecting reference and experimental population. Third step is randomization. Fourth step is manipulation or intervention. Fifth step is follow-up. Sixth step is assessment of outcome. Number one, the protocol. The protocol forms the main part of the randomized controlled trial and is also known as the heart of the randomized controlled trial. The protocol usually has the following things, or it specifies the following things. Number one, the aims and objectives of the study. What is the aim of the study? What are the various objectives of the study? What are the various questions that need to be answered? What are the various criteria for the selection of the study and the control group? What should be the size of the sample? What are the procedures for allocation of subjects into study and control groups? What are the treatments to be applied to the study group? What is the standardization of working procedures and schedules? And what is the responsibilities of the parties involved in the trial, starting from the beginning to the end of the trial? A protocol is essential, especially when a number of centers are participating in the trial. So basically, protocol forms a very important part of a multi-centric trial. Once a protocol has been evolved, it should be strictly adhered throughout the study. It means that you cannot change in the middle of the study, and what are the conditions that are put up in the protocol has to be strictly followed. The protocol aims at preventing bias and to reduce the sources of error in the study. That's why it has to be drawn first. Before the protocol, pilot studies with the minimum number of subjects have to be done. It is important that the final version of the protocol should be agreed upon all concerned before the trial begins. Now, selecting the reference and experimental population. What is reference population or target population? It is a population to whose the findings of the trial, if found successful, are expected to be applicable. It means that whatever the trial you are doing, if it is found to be successful, the results of the trial can be applied to this population. So it can be either a drug, vaccine, or other procedure. The reference of the target population can be people living in a particular country or in a geographical area, or it can be school-going children, or it can be workers in a particular factory or obstetric population, like that. Experimental or study population. Now, this experimental or study population is derived from the reference of the target population. It is the actual population which participate in the conduct of the randomized controlled trial. The participants or volunteers who are participating in the trial must fulfill the following three criteria. They must give informed consent. So the consent usually has to be given by the participants, and they should be usually signed and taken. So before signing, giving the informed consent, they are well explained about the procedure and the conduct of the randomized controlled trial. Now, they should be representative of the population to which they belong to. That is a reference population regarding the age, characteristics, or occupation, or any physiological condition. They should be qualified or eligible for the trial. It means that, as understood from the following example, if you're doing a study or randomized control trial on anemia, the participants must be all anemic, so that the manipulation, that is iron folic acid, is given, which subsequently helps in the cure or treatment of this anemia. So this iron folic acid is usually given to the experimental group, and the control group is given usually a placebo. They must be fully susceptible to the disease under study. So both the study group and the study experimental or the control groups both must be susceptible to the disease under study. So unless they are susceptible to the disease under study, probably this cannot be done. The other example is vaccine given for whooping cough. If both the experimental and the control groups are immune, then the effect of the vaccine cannot be fully understood. So they should be susceptible for the disease, so that even after giving the vaccine, even on giving the vaccine, we can easily study the effect of the vaccine and in the experimental group. Randomization. Now we had discussed about randomization briefly just before the start of the flow diagram of randomized control trial. So randomization is a statistical procedure by which the participants are allocated into study group and control group to receive or not to receive an experimental, preventive or therapeutic procedure, maneuver and intervention. So randomization is basically a statistical procedure. So it helps to divide the experimental population or the study population to be divided into experimental and control group. So this is usually done with the help of a random number table, which is usually found in books of statistics. And randomization is an attempt to eliminate bias and allow comparability. But what is bias? Bias is any systematic error associated with the cause and effect. Randomization is the heart of a controlled trial. It gives the greatest confidence that groups are comparable and like can be compared with the like. It eliminates selection bias because the experimental group is divided by the random number table into experimental group and control group by means of random number table. So we do not select specifically who should be in the experimental group and who should be in the control group. In that way, the bias is avoided. So randomization helps in eliminating selection bias. Randomization is best done by using a table of random numbers, which I'll show in the subsequent slide. The essential difference between an RCT and analytical study is that in the later, that is in analytical study, there's no randomization because a differentiation into a disease and non-disease groups has already taken place. The only option left to ensure comparability in analytic studies is by matching. So this is a table of random numbers which helps in the allocation of this experimental group or study group into experimental and control groups. Manipulation. After making necessary exclusions in the experimental or the study population and dividing them into randomly dividing them into study experimental group and control group, we now need to manipulate. So the next step is to intervene or manipulate the study group by deliberate application or withdrawal or the reduction of the suspected causal factor. So in one group, either you apply or withdraw a suspected causal factor. This can be either be a drug, so this can be either be a vaccine or dietary component or a habit, as laid in the protocol. So as we discussed about the drug, that is about iron folic acid tablet. Vaccine, again, we discussed about a whooping cough, like that. Vaccine for a whooping cough. So this manipulation creates an independent variable, that is drug, vaccine, and new procedure, whose effect is then determined by the measurement of dependent variable, that is incidence of disease, survival time, and recovery period. Follow up. Now after manipulating, we need to follow the experimental group and the control group at varied intervals of time in a standard manner with equal intensity under the given same circumstances in the same time frame till final assessment of the outcome. So the circumstances has to be similar to both the groups, and similar time period has to be outlined before the start of the outcome. The follow-up may be short or may require many years depending upon the study taken. It may be mentioned that some losses will be there to follow up are inevitable or cannot be avoided, and this is known as attrition. So attrition can be due to the death of the participants or due to the change of occupation or due to migration, the various factors that can lead to losses of the participants in the follow-up. Assessment. The final step after follow-up is the assessment, and the assessment of the outcome can be in positive results, that is the recovery of the person from the disease, or and the negative results, that is increase in severity of the disease or increase in fatality. So here bias may arise from errors of assessment of the outcome due to human element. And there can be three sources of bias. First, there may be bias on the part of the participants who subjectively feel better or report improvement. This is what is known as subject bias or subject variation. Second is this observer bias. There may be bias with the investigator who, who feels that the people who are given the drug, uh, they're performing better. Thirdly, there may be bias in evaluation, that is evaluation bias, where the evaluator feels that the people who are given the drug, they get recovered or they get cured compared to the people who are not given the drug or not given any intervention. Randomization cannot guard against this sort of bias nor the size of the sample. So in order to reduce these problems, a technique has now been adopted, which is known as blinding. And this ensures that the outcome is assessed objectively. And blinding is usually done in three ways: single blinding, single blind trial or single blinding, single blind trial, double blind trial, triple blind trial. Of these, the double blind trial is more frequently used, but ideally the triple blind trial should be used. When an outcome such as death is being measured, blinding is not so essential. In a single blind trial, the participants, that is do not know whether they belong to the experimental group or study group and control group. In the double blind trial, the participants and the doctor are not aware whether the participants belong to the study group or the control group. Triple blind trial, the analyzer or the evaluator along with the doctor and the participants are not aware whether they belong to the study group and the control group. So as I said earlier, double blind trial is more frequently used, but the ideal is a triple blind trial. But when we are discussing an outcome such as death, blinding is not essential. Now, some of the study designs as mentioned in randomized controlled trials are concurrent, parallel type of study designs and crossover type of study designs. As you see in this figure that is mentioned in this particular slide, that is in part A, you randomly divide the patients into experimental group and control group. Experimental group are those who are given a specific treatment, and control group are those who are not given a specific treatment. This is again by a process of randomization. So you observe this group for a period of time and you compare the outcomes. So this is known as concurrent parallel type of study design. In crossover type of study design that is given in B, you again divide the patients into an experimental group and control group. To the experimental group that is subjected to a drug or a manipulation, and a unexposed group that is a control group is given a placebo, and both are observed for a period of time. Then the experimental group, the drug is withdrawn, or the manipulation or the intervention is withdrawn. Similarly, the placebo from the control group is also withdrawn for a period of time till the effects of the drug are worn off. Then the drug is again given to, then both the groups are swapped. Then the drugs are given to the opposite group, that is those who are not earlier exposed to the specific treatment, and the placebo is given to the exposed group who were earlier given treatment, and the outcome is compared to both the exposed and unexposed groups. In this way, those who did not get the drug again get the drug, and in this way, more number of study subjects are not exactly required. So these are the two types of study designs which we have studied. Subsequently, the various types of randomized controlled trials will be discussed along with the other topic, that is the non-randomized trials, in the subsequent class. So as we understand that the most important part of the randomized controlled trial, we should know the various steps. So going back to steps. So you should be able to by heart and write this whenever a question on randomized controlled trials are given. So a question may come in the university examination like uh, classify epidemiological studies, write in brief the various steps, write briefly the various steps involved in a randomized controlled trial with suitable examples. So here, the first thing is you need to remember what is a reference population or a target population, that is a suitable population. Then by various sampling methodologies, you select a suitable sample from them, which is also known as the experimental or the study population. Then you make necessary exclusions, those who are eligible and those who do not wish to give consent for participating in the study. And then you do a process called randomization, which is a statistical procedure which allocates according to the random number table the subjects randomly into study group and the control group, or the experimental group or the control group. Then you apply an intervention to the experimental group. This intervention is also known as manipulation. And to the control group, either you give a placebo or you don't give any manipulation or intervention. Then you follow up after this manipulation to see whether there are whether you follow up whether this intervention has any effect in the experimental group. Then you further assess whether there is any positive effects, that is the decrease in the severity or the decrease in incidence of the disease in the experimental group, or whether there is an increase in frequency or increase in incidence or severity of the disease in the experimental group and compared to the control group. And in such a way, you can actually do this. And usually randomized control trials, we do a process called blinding, single blind, double blind, and triple blind. So it's very important in the single blind trial that the participants can belong either to, they are not aware whether they belong to experimental group or control group. Then double blind trial, the participants as well as the doctor consent are not aware whether the participants belong to the experimental group or the control group. And the triple blind is the participants, the doctor, as well as the evaluator or the analyzer who analyzes the entire study is not aware whether the participants belong to the experimental group or the control group. Ideally, a double blind trial is very important. Usually followed, but ideal is a triple blind technique that is being followed. So I thank all of you for attending this class again, and do remember randomized control trial is a very important topic, and one should understand and master these steps when writing this language. Thank you very much.